Hello, everyone. Welcome to the HL7 open source tooling series. Today, we'll share with you smart health cards and links and some work from the Commons project. And so I introduce to you Josh Mandel from Microsoft. Welcome, guys.
Well, thank you so much. And we're delighted to be here today to talk about work that we've been doing over the course of the last few years on a set of standards and open source tools for working with those standards. I don't have formal slides, but I do have a set of links to all the content that I'll be showing in screen share. I just put that in the Zoom chat, and I think we'll have to repeat it there a few times just to make sure that folks who join after this moment still have access to it. But I wanted to get started and talk about some of the use cases and motivations for these specifications, which are focused on consumer-facing interoperability and helping individuals to share verifiable health information about themselves. And I'll talk a little bit about the specifications and the problems that we're solving. And I'll show a few of the developer-facing tools and demonstrations that we've put together to make it easier to work with these specifications and adopt them for real-world use cases. So really quick introduction to smart health cards. What you're looking at on the screen here is a landing page for a consumer-facing site. This is a little bit unusual for us in the standards world. Mostly we focus on developing specifications that look, something like this. This is a FHIR implementation guide, and these are meant to be read by developers and folks who work on health IT as their day job. But this is a site that's designed for consumers who might have access to their health information. And it's very important that they understand what this technology is all about, how it can help them, what the limitations are, and what their choices look like. So this site is smarthealth.cards, and it takes consumers through the basic orientation of what a health card is. And roughly that is some kind of artifact that you can get. Once you get it, you can save it and keep it with you. And then you can share it with others when you want to be able to make them aware of certain kinds of health information. And one of the driving use cases for the development and the dissemination of this work was the ability to share vaccine histories for the COVID-19 pandemic response. And throughout, for smart health cards, it was very important to make sure that these technologies could work for people with and without smartphones. So smart health cards is designed so that you can share your information in a QR code, which you could display on your phone, or you could also print it out on a card in your wallet and save it there. And that will be a common theme in terms of being able to print out and share access to health information. This specification also helps consumers understand some of the limitations around health cards. So like when you share a smart health card with information about yourself, it's a lot like showing somebody a physical document like a driver's license or a printout of your health record. Once they've seen it, you don't have any technical mechanism in place to prevent them from misusing that information. So it's very important from a consumer perspective to only share this kind of information with individuals or organizations that you trust. And at the same time, there are privacy considerations that are built into the way that we design these specifications. And the most important of that is limiting the set of data that goes into these health cards. So I won't spend much more time on the consumer overview, other than to say this site is available and is designed to take anyone through a workflow of understanding what health cards are all about. I want to spend a bit more time on the technical specifications. And this is work in progress to bring together the specifications that were written across a couple of different communities and pull them together into a single HL7 balloted specification. So moving through the formal consensus process within HL7 so that we can get broader community review and adoption. So this draft specification is in the HL7 ballot process right now. It's open and available for comments. And it goes through how to use smart health cards and health links, which we'll talk about in just a moment. But the key area for health cards is this specification page that explains sort of step by step how you can take a FHIR bundle that has a little bit of vaccine information in it, for example, and turn that into a signed computable artifact that can be shared as a QR code. And I won't talk through all of the details of this specification, but maybe one of the simplest ways to think about this is to look at the set of examples in the spec itself. So there's a page called Health Cards Examples. And we can think about, for example, somebody who's received COVID-19 vaccine doses. We start by thinking about what do the data look like in FHIR. And so in this case, we represent the information as a bundle with just two resources in it. The first one is a patient, which tells us who received the vaccine. And we try to limit the amount of personal information that goes into this patient resource the guiding principle is that there should be enough information here to be able to match it with an additional factor of identification. So maybe you would present this alongside a driver's license or an ID card and make sure that the name and birth date matched that physical document that you were showing. And then there's an immunization resource, which links to that patient, which has the basic details of what vaccine did you receive, when did you receive it, and where did you receive it, or who administered the vaccine, as well as the option to include a lot number. And so in this particular bundle, there's one patient and there's 3 immunization that all look very similar, but represent different doses that were received on different dates. And that's always the starting point for creating a smart health card. Once you've put that FHIR bundle together, you sign the bundle using a format called a JWS, JSON Web Signature. I won't go through all the details of that signature process, but it's a standardized flow that we describe. And it results in this kind of cryptic looking base64 encoded JSON Web Signature token. This is not something we expect individuals to see or copy or share directly, but rather it's something that can be put into a downloadable file, or it can be displayed as a QR code. And this is something that could be printed or shared on an individual's phone screen. So that's a quick tour of what Smart Health Cards is all about. At the end of the day, we have a FHIR bundle. It gets signed and it gets packaged into a QR code that looks something like this. There's a lot of material in the specifications that help developers understand what's involved in creating and in parsing one of those QR codes. But we often find that the best way that developers learn is by trying it out, looking at real examples, and attempting to build their own. And so there's been a lot of community work to put together libraries to help developers do just that. And the one that I'll point out today is called the Verifier portal. So demoportals.smarthealth.cards. There's 2 components to it. One that shows you the experience as somebody who wants to be able to create a smart health card, and the other that shows you the experience as somebody who wants to verify a smart health card by reading that QR. And each of these goes in a step-by-step fashion through those processes. If I wasn't already using my webcam to talk with you all, I could scan a QR code and parse it that way, but I just put onto my clipboard the content that would have been parsed. And we can see step-by-step how we go backwards from the QR code into that FHIR bundle. At first, there's a decoding step that gives us this base64 encoded JSON blob. And then there's a decoding step that gives us the full signed payload. We can verify the signature on this and get some helpful information here. Like this is an old style health card that has some additional types assigned to it that we don't recommend anymore. So that help comes in line. This is my real data that comes from an Epic portal that I have access to for my healthcare provider here in Wisconsin. And that healthcare provider includes their public key, which they host openly on the web. And so this tool is able to download that public key from my healthcare provider's website. It's able to check the signature on my document using that key and show us that that signature is verified. It's a correct signature. And then at the end of the day, it just displays that FHIR bundle, which indeed has information about me and at least one of the COVID vaccine doses that I received. So I actually have separate QRs with information about some of these different vaccine doses. And that's a good lead into our discussion about smart health links. But this is the kind of tool we provide. And under the hood, I've shared links to a set of Node.js libraries that we use to build this verifier portal and this developer portal. And these libraries can be used in a standalone fashion to test and look for any bugs in a smart health card that a developer has generated. And there's also a step-by-step flow for just taking a FHIR bundle and creating a QR code from it right here in the browser, as long as you can supply the keys and the underlying FHIR material. So those have been really useful developer tools. But as I mentioned, in the real world, an individual might have many different pieces of their clinical record that are separated out in different places. And it can be hard to keep track of all those things. We know that there are use cases that need more data than we can pack into a single QR code. And so that has driven work on a companion specification that we call Smart Health Links, which is designed to work with smart health cards, but address a few of the issues that we notice when it comes to smart health cards deployment. So one of the goals of Smart Health Links is to allow people to share data sets that are just larger than the data you can fit in a single QR. So you might have something like a full health history or summary. Another goal is to be able to share data that are dynamic. So you might want to share your vaccine history, but be able to share an update so that the recipient of those data can always be up to date with the vaccines that you've got. And if you have a new booster vaccine, maybe you want the recipient of that health link to know about those new boosters. So that's a use case for what we call dynamic data. And I want to show you a couple of examples. I'll give you a quick view of the health links specification. The overall concept here is that instead of putting all the data in the QR code, we are encrypting the data and putting a link to the encrypted data in the QR code. And then there's also a decryption key that's conveyed in that QR code as well. There's a little bit of a protocol for how you get access to that encrypted data set based on what's in the QR code, but it's probably easier to talk about through a demo. So I'm going to show you a couple of additional open source tools that we've put together that implement this Smart Health Links specification and show how to retrieve data from one of those links, as well as generating a link. So one use case would be sharing a complete vaccine history. Maybe you want to be able to share this with a child's school. So in that example, you might create, I'll just start from scratch here. You might create a new health link that's going to have all of the child's school vaccines. And you have the option to attach a passcode to that health link if you want to add further protection to it. And you have the option to include an expiration date to it. But by default, we'll just share all the vaccine history that this fictitious child has received by activating a new sharing link. And then we can display that to anybody as a QR code. Or since this is just a web link, we can also copy the link itself to our clipboard. So in this example, that's what I'll do. We'll notice that the access count is 0. If anybody in the audience has a cell phone and is scanning this QR code, we may see that access count jump up, but I'll give it a shot and open it in a new window myself. So if I paste in that Smart Health link in, I have this very sophisticated viewer that downloads and decrypts all the content and then displays it as a bullet list of JSON. But there's a standardized protocol by which this URL component can be extracted and used to reference the link. And it looks like I'm accounting for one of these 6, so at least 5 folks in the audience have been able to follow it as well. So that's pretty cool to see. And it also highlights one of the design goals for Smart Health Links is that individuals should be in control of these links. And if I want to deactivate it, if you still have that link around and you try to follow it again, it's not going to work anymore. So sorry to the rest of you who wanted to give it a shot. I'll make a new one. But that's the basic goal for Health Links. And you should know as a consumer if people are following your link, or you should at least have the option to know. And so that's part of what goes into this discussion about access counts. So that's a use case that's really focused on vaccines. You'll hear a little bit more about that in a moment from Patrick. I want to show you a couple more use cases that highlight some of these capabilities. So one is my own glucose data. And again, if you scan this link from your phone, you should have access to this same Smart Health link and the same view that you see on the screen here. But I want to point out a couple of interesting things here. So as part of this year's Argonaut project on continuous glucose management, I've been digging in and writing some specifications for how to share CGM data. And there can be a lot of information involved here because these sensors, which you wear for a period of 2 weeks at a time, can create a new reading every minute or every 5 minutes. So if we look at what's happening here, there's actually about 4,000 FHIR resources. Those are mostly observation resources that are being used to generate this view. But anybody who's got this link, which you can copy to your clipboard here, or scan as a QR code here, or if you're on a mobile phone, you can click the share button to share it out to anybody who can receive links. Anybody who has this link will be able to see this view, but more important, they have access to the underlying FHIR data. So I've included a little download button here. If you click this, you'll get a FHIR bundle with those 4,000 resources. And the important thing is that health links are designed to be computable in this way. So it's not just taking somebody to a website where they can see an overview. The overview is nice. It's an important fallback. But the real goal of Smart Health Links is that if you've got a health IT system that knows about FHIR observations, and I share this link with you, you can import or process those observations in any way that you see fit. You never have to look at this web page. You never have to open a web browser. You can do that entire process just using a backend script that downloads this link, follows the data, and decrypts it. So this web view is really just a fallback. So that's an example in CGM where we have dynamic data. So if I'm wearing the CGM, this will be updated tomorrow with my new data. Although I'm not wearing a sensor right now, I'll probably have one on towards the end of the week, and we'll see updates happen. If you save this link today, it'll keep working over the course of this project. And the last example that I'll show you is one for sharing a bigger data set. So this one is, actually, let me just start from scratch here. This one was focused on being able to share an international patient summary document. And that is a format that's produced as a FHIR bundle in what's called a document, which can include a patient and many different sections of their health history. So by default, you can upload your own history file or smart IPS summary file. You can upload that JSON with this web form, or just to make the demo easy, I'm pointing to an open source example that's hosted on one of the HL7 demo servers that you probably heard more about in another one of these sessions. And so by default, I can just create a Smart Health link from either one of those sources. And I'll create one that's just going to last for an hour. And I'll just call this SHL demo. And this is using the same underlying API server to host the encrypted content as the last couple demos that I showed you. And I can configure this with a passcode if I want to. I can update the label. But anybody who scans this link will be able to get to a viewer that looks like this, again, with the content automatically loaded in it. And again, the viewer here is just a fallback. If you're building an EHR system that's designed to store summaries natively, you never have to show your users this view. You can simply follow the link and automatically decrypt and retrieve this bundle so that you've got the full content ready to import into your system. However, we know that not everybody has an EHR with those capabilities predefined. So we thought it was very important to have some ordinary functionality for these links. So if a user doesn't know what they're all about and just follows the link, they get to some meaningful view of the data. So that's a quick overview of the goals for Smart Health cards and links. And with that, I want to pass over to Patrick. If there's questions, please do share them in the Zoom Q&A. We'll have time to triage and answer questions toward the end of this session.
Thanks for watching. If you found this helpful, give us a like, subscribe, and hit the bell so you won't miss the next one.